functions that you have to know. Okay, so dissect the question. First, you see that fx, right, is equals to x squared plus 3x minus 1. And they say that x is smaller equals to k. First thing, given that f inverse exists, state the largest possible value of k and using this value of k to find the f inverse. So first, go and plot it out into your GC without any domain. You will realize it's quadratic, right or not? Okay, can the quadratic be 1, 1 at this point of time? No, right? Yeah. So what you need to do is you need to go and use second function calculate to find the minimum point. Okay, if you find the minimum point correctly, this part is negative 3 over 2, comma 13 over 4. Look here, there's a lot of things to understand. The first thing, when you see a quadratic, you must know that you can use your graph to go and draw this and then draw this out. Okay, that's fine. When will the graph have 1, 1? Or wait, can you see it's lesser than k? So it's which part? Is this part, right? Yeah. So what is the biggest domain such that it can have 1, 1? X must be lesser equals to, we are looking at x, right? Negative 3 over 2. So therefore, k is equals to negative 1.5. Most of you, I think, got this part correct by drawing, either by drawing the graph or not by drawing the graph. But another thing I want you to note is, you look at this. Okay? When you see an inverse coming, right, own self, you must think of the range. Okay? The range of f is equals to, so look here, this is a minimum point. Range means talking about x value or y value. Y value. So the range of f is from 13 over 4 all the way to infinity, like this. This part understand? Why? Because the range of f will give you the domain of f inverse later on. You will need the domain of f inverse later on. Understand? So it's good to have a small sketch of this to understand where is the range. Okay? So now the question asks, find the f inverse. So A, what is the technique of finding the f inverse? Let y equals to x squared plus 3x minus 1. Okay? But in order to make x the subject, right, the only way I can do is complete the square. You realize that this paper, I keep asking you all to complete the square, complete the square, complete the square. It's because complete the square will always come out. Okay? This will become x plus 3 over 2 square. Oh, this is a minus. So, sorry, this is a minus. This is negative 13. Okay, minus 13 over 4. Okay, look here on how I can make x a subject. Look here. Y plus 13 over 4 is equals to x plus 3 over 2 square. X plus 3 over 2. When you square root, you must always have a plus minus. Listen up, guys. Y plus 13 over 4. Then x equals to plus minus square root of y plus 13 over 4 minus 3 over 2. Now, there's two functions of inverse. One is a positive one and one is a negative one. Look at the graph. We want the positive one or the negative one? The negative one. Can you see? Because we want x lesser than k. We want the left side. So therefore, my f inverse x is equals to the negative square root x plus 13 over 4 minus 3 over 2. This is where the next part is important. What is the domain of f inverse? It's actually, you can look from here. Actually, you can look from inside the square root. But an easier way would be look at the range. Negative 13 over 4 to infinity, right? Yeah. X is greater equals to negative 13 over 4. That would be the domain of f inverse. Because the domain of f inverse is equals to the range of f. What is the relationship of f inverse? All the x become the y value. All the y become the x value. That's the relationship of fx and f inverse. That's why in part B, okay, the question asks, find f inverse x equals to fx. Before we talk about the answer, what is the relationship of fx and f inverse on the graph? It is a reflection on the line and y equals to x. That means if let's say you have this point here, which is negative 2, 1, it goes here. The reflected point would be here. The x becomes the y becomes the x. Here, 1, negative 2. Can you see? This is fx. Reflect down here. Can you see? This is f inverse x. And all three, the graph, fx, f inverse x, and x, they will all meet at the same point. in order to do this kind of question, first thing you must write f inverse x equals to fx is also equals to x because they all three meet at the same point. Understand? Which is the easier way to solve? This is the easier way to solve. Oh, fx equals to x squared plus 3x minus 1 equals to x plus x squared plus 2x minus 1 equals to 0. Can you read the question? They will ask for exact, right? Exact means what? Third form. 100% third form. To do this in third form, what do? The easiest one is quadratic formula. Minus b plus minus square root b squared minus 4ac over 2a. You will get minus 2 plus minus square root 8 over 2. 8 in terms of third form must know n root 8. See, these are the skill that you have to know. Over 2. The answer is minus 1 minus root 2 because everything divided by 2. Sorry, minus 1 plus minus root 2. Now we take positive guy or negative guy. Again, we look at the domain of f inverse. We want the left side, right? Yeah. So therefore, the x have to be the positive guy or negative guy. Negative guy. Why? Because we take the left side. The left side will be the negative. Yeah, the negative value or the left side. F prime inverse x is the x lesser than k, ma? Okay, can. So this is for B. For C, composite functions. Okay, what is the definition of composite function? Is the range, okay, so look here again, look here. Many students don't understand how to find the range of the composite function, which is the last part, okay? But you all know, most of you actually know how to find the, or whether the composite function exists. So look here. The question did tell you that fx is equals to x squared plus 3x minus 1, or they say that x lesser equals to negative 2. Look here. So this is the domain, right? This is the domain. When I do composite function, I will always write these two things down. This part is the domain. Okay, I will write down the range. The range of f is equals to, be careful, it is not from here anymore. It is not using the first part anymore. I will use my calculator. Okay, and plot out. But actually, I know that it is going to be a quadratic like that. So I sub in negative, when x is equals to negative 2, my y is equals to negative 3. Okay, so what is the range of f now? Negative 3 to infinity. This part understand? Okay, because they tell me that my k, right, be equals to negative 2. Just use your calculator. You can trace it to negative 2 or second function value. Wait for my calculator to load. I have too much. It's actually here. Okay, later I'll show you. Now we look at gx is equals to the square root of x plus 5. You realize that the square root of x plus 5, again, I will write the domain. Look, can you see here? Minus 5. Okay, so greater equals to minus 5. The range of g, right, is actually, when they put minus 5 inside, you'll get what? 0, right? Yeah. It's from 0 to infinity. How I know it's to infinity? Actually use the graph. Okay. Square root x minus 5. Is it x minus 5? Plus 5. Okay. See, now I draw the graph. Okay. Standard things I write. I do. Zoom standard. Can you see? Well, y is 0, it will keep on increasing. There's no asymptote for square root graph. Okay? It will just keep on increasing. So that's why it's from 5 to infinity. Sorry, range is from 0 to infinity. Use the graph. Always use the graph to find your range. Okay? Now, which one can fit into which one? So the obvious one would be, can you see the range of f can fit into the domain of G? Can. So range of f is a subset of domain of G. Why? Negative 3 to infinity is smaller than negative 5 to infinity, ma? Yeah.
What's the definition?
What do you mean?
Give a definition.
You ask me up 10 times. It's just an equation. Okay, it's just an equation. Range of f is a subset of domain of G. Therefore, in this case, is fg or gf?
Yeah.
gf exists. Okay, find the definition of gf. Oh, gfx is equals to g of, put in the fx, x squared plus 3x minus 1. So g of this is equals to the square root. Replace your x with x squared plus 3x minus 1 plus 5. And then you get square root of x squared plus 3x plus 4. Domain of gf is equals to domain of f. During this time, you can perform very well. The exam paper come, forget everything. Okay? Domain of f, so x is less than equals to negative 2. Okay? Again, why is it that for the composite function to exist is this way? Again, it boils back down to the tree circle. This is my x. Okay? This is my x. Let's say I'm talking about gf. I will undergo through f. After I undergo through f, I will get the range of f. This part is because it's the y value. Understand or not? Okay. Now over here, to do gf, we are doing f first, right? Not. Now we want to do g. The y value of f, right, becomes the domain of g, such that it undergoes through g to get your new range of gf. Listen here, understand? The x undergo through f becomes the range of f. Range of f is the y value of f, right? Not. Now, I need to, because it's like a factory, I need to go through two-step process. I'm taking the end product of the f to go through another process of g. So the range of f will now become the domain of g, undergo through g. Then it becomes the new range. So when you want to find the composite function of gf, I look at the range of f, which is, use the graph, negative 3 to infinity. This will become my domain of G. Understand? Then this is where the interchange happens. Can see? To find the range of a composite function, take the range of the inside function to become the domain of the outside function. Okay? Plot it into, plot it into your GC. Not say plot it into your GC. We can look at it as, now what is gx? Gx is equals to square root x plus 5, right? Not? Put it into this function. That means I know that the graph is from like that, right? It's increasing, right? Yeah. So all I need to do is to sub my x equals to negative 3. My y is going to be equals to square root 2. This part can understand? Can. Okay? Square root 2. So therefore, the range of fg is, sorry, gf is from square root 2 all the way to infinity. Okay? This is gx, but the original domain of gx, right, is from negative 5 to infinity. Can see? But because I can, in order for this to exist, I can only take from negative 3 to infinity, because the y values of the fx is from negative 3 to infinity. So take the starting position, negative 3. I put in negative 3, negative 3 is here. The y value is square root 2. This is the part where gf exists. Okay, so this is the range of gf. I'm taking from negative, it will start from negative 2, it will go all the way up.
Wait, what's RF negative 3? What's it not like 1.5?
Range is y value.
But isn't the minimum y value at 1.5?
It's not. In this question, take k to be negative 2. Okay?
But besides, to find range of composite, isn't it better to just just use the domain of the composite and then just plot the graph, then from the graph also?
I think it will still work. I think it will still, it might not work for, not say, sometimes you don't have the equation. Sometimes the equation they can just show you from the graph only. You know what I mean? Yeah. Okay, so yes, another way which could be easier now if you don't really understand how to go and do this one, right? Yeah, the easiest way would be, oh, I already have gfx, right, which is square root of x squared plus 3x plus 4 or x lesser equals to negative 2. Okay, plot this out and see whether is it an increasing function or a decreasing function. Okay, so if it's an increasing function, I think when you do sub x equals to negative 2, you will get y equals to square root of 4 minus 6 plus 2 plus 4, I think. Yeah, nice. You will also get, can you see you will also get square root 2? Therefore, the range of gf is equals to from square root 2 to infinity, and that's it.
Wait, what? Wait, how's the? Oh yeah, x minus 2 for what? Because k is.
Because the domain of gf is equals to the domain of f. Yeah.
Because if we grab a function, always must have the domain at the back.
Yes. This way will be easier if you have an equation. Understand or not?
So let's see the function.
You are not sure on why is it the range of f is negative 3 to infinity, right? Because it is a quadratic function of x squared plus 3x minus 1.
Also, maybe one stream.
The turning point is not 3. It is above the turning point. Tell me the equation again. X squared
X squared plus 3x minus 1.
plus 3x minus 1, right? Okay, what is the domain? X lesser than equals to negative 2, right? So my x maximum, I put it as negative 2. This part can understand? Because negative 2 backwards, man. Okay, then I press the graph. Can you see it's a U shape going up?
Yeah.
Yeah, it's an increasing function, right? Okay, I can press trace. I trace it to x equals to negative 2.
But isn't negative 1.5 the lowest point?
Yeah, so what negative 1.5 is here, right? But the question says that take k to be negative 2. They change the domain to be negative 2 backwards. Understand? They change the domain to be negative 2 backwards. The turning point is there, but this point is negative 1.5, comma, negative 13 over 4. Okay? The question says in this case, take k equals to negative 2, and the domain of f is x lesser equals to k. Where is negative 2? Negative 2 is here, right? When x is negative 2, y is negative 3. This part can understand?
Yeah.
So we are only taking this part.
But it's not a turning point.
It's not a turning point, yeah. Okay, can? Because the question changed the turning point. Understand?